5,000, 97,000, 12, 8, 6, 5, 0, and 16, 2, 6, 0, 5. Now these are big numbers, so we're going to make sure that our y axis is going to be able to show those. And let's go ahead, we're going to build a new page, and we're going to build a data and statistics page. And our data is going to come up. We're going to go on the bottom here. We're going to want to click for year. And then over on the other side in our y-axis, we're going to want to click for population. And we get this nice curve. We want a logistic model. So we're going to go to menu. And we're going to go to actions. I'm sorry, we're going to go to analyze. I'm sorry, actions. Regression. And then we want to show a logistic. We're going to go d equals 0. That's our initial value. It's going to think about it. And we've got our logistic function. Now our logistic function is right here. So I'm going to grab this and move it up so we get a better look at it. Okay, so I'm going to go and copy that down onto a piece of paper here for our logistic model. Let's see if we can see this here. Okay, so we've got a calculator here. Y equals 484925 over 1 plus 27.5 e to the negative 0.03 x. Now I rounded it here. It's nice that the calculator, what the calculator does is it gives us this 484 and it gives us a 1 here. So it's going to make it easy to find what that limit to growth is. So let's look at the next question here. And the next question says, what is the limiting value of the size of the Jewish population of Toronto according to this model? So that's, if you remember, that is the limit to growth. It's the highest value, the top horizontal asymptote that we're going to have for this particular logistic model. And I just said it's nice that it's over 1. So it's just going to be this value over here. So our horizontal asymptote, which is the limiting value, is going to be 484,925 people. Part C says, give the coordinates of the inflection point on the curve. Interpret this in the context of the data. So what we're looking at is where is it going to go from concave up to concave down. And what this means in the context of the data is that our population is increasing, it's getting steeper and steeper. So it's increasing faster, and then right at the inflection point, it starts to increase slower. So we're still increasing our population. It's just that that rate of increase is slowing down. And so to find that, we know that it's just going to be this for logistic models, it's going to be halfway in between the horizontal asymptote at the top and the horizontal asymptote at the bottom. So we know that this value here is going to be halfway in between 0 and 484,925. So we're going to just divide that by 2. And we're going to get this to be 242 about 463. So this is our y value. So if this is our y value, we're going to need to have we're going to need to find the x value, and to find the x value, we're going to need to plug that y value in right here for y. So we're going to do that. So we're going to go 242,463 equals 484,925 over 1 plus 27.5 e to the 0.03x. Now we're going to solve this, and we solved this problem in the class the other day. So we're going to take all of this and multiply it up to the top. And so what I'm going to do is I'm going to skip a step here.